Next several days we're going to go over systems of equations applied. A farmer's market is selling apples for $1.99 per pound and oranges for $1.50 per pound. You buy 12 pounds of fruit, you spend a total of $21.92. How many pounds of apples and how many pounds of oranges did you buy? So that's what we have to figure out. Now, you can't use the XY input-output table in the line on this, okay? Because there's three different units, okay? See, the X and Y table is only good if you have two significant units, an independent variable unit and a dependent variable unit. Here we have three different units, apples, oranges, and dollars. So you don't want to be making like an XY table. That's not going to work because there's two categories of things we're paying for. Now if I had dollars and oranges, I could make a table for oranges and dollars, but I've got two different things. So what I do when there's three units, the dollars is the dependent unit, and then the two categories of things we're spending the money on is apples and oranges. I make a table. Okay? It's a 9-box grid. Okay? This is your together column. These columns are the two categories of things you're purchasing in this case, which would be apples and oranges. So apples and oranges. And then, of course, we're purchasing them together. Now, down the rows here, it says how many units, and then per unit in total. Now, since dollars is what we're spending on these two things, that's your dependent variable unit, dollars. You put dollars above total and dollars above per unit, but not above how many units, because how many units is like how many pounds of apples, how many pounds of oranges. Okay. Now, here's the first thing we're going to do. We are going across the top row. How many units means like how many do I have, not what they cost. So that doesn't belong in the top row. That's a cost. That's a cost. 12 pounds of fruit, okay? 12 belongs here. And it's 12 pounds of fruit together. Now these are unknown, okay? Those are the answers to my problem. So I don't know either one of these. So I'm going to let this be represented with X, this be represented with Y, and that's an equation. X, I know that X plus Y equals 12. Now, after that top's been filled out, you're going to jump to the bottom row and fill out your money total. The money total is $21.92. Okay, and that's what you're equal to down there. So that's going to be our second. We got one equation here, a second one here. Now, if I know the value here and I know the value here, this is not needed. Okay. Now, cost per unit. How much do the apples cost? Okay, so I know we got the 12 accounted for and the $21.92. So apples cost $1.99 per pound, and the oranges cost $1.50 per pound. Now, to get from here to here, so you don't know how many units of apples, but you know the cost per unit is $1.99. So you're going to take these and multiply them. You're going to multiply X by 1.99, and that's expressed as 1.99X. Okay, plus Y times 1.50 is going to be expressed as 1.50Y, because we know what they cost, we just don't know how many of them we have, so we write that expression. Now I have the two equations, X plus Y equals 12, and then $1.99X plus $1.50Y equals 21.92. Now what I like to do when I stack these two equations is kind of make a grid across here, okay? So I stack them up, X plus Y equals 12, and then $1.99X plus 1.50Y equals 21.92. Now, you could subtract the Y or the X and use substitution. I would just arrange the columns and go with elimination here. That's your best bet. So $1.99, so I multiply by 1.99 across the top. Remember to multiply the 12 by 1.99. And then the bottom you're multiplying by 1. So 1.99 times 1x is 1.99x. 1.99 times 1y is 1.99y. And then 1.99 times 12 is 23.88. Now the bottom is just the identity property because you're just multiplying it by 1. Now redraw your columns. And again, we want to drop the x's so we make it negative. But then you got to make your 1.50y negative and your 21.92 negative. And then these add to 0x. Okay. Then 1.99 plus negative 1.50 is 0.49y. Then 23.88 plus negative 21.92 is 1.96. So the 0x drops the x out. Now I divide each side then by 0.49. And that answer is 4. So y equals 4. Now go find your y variable where it's all by itself, and you now know that this is 4. So you have 4 pounds of oranges. Now you can plug 4 into one of these equations, but if you think about it, we're trying to find the apples. Well, what plus 4 equals 12? Well, how about I just subtract 12 and 4, and I believe it's 8. Okay, so you can plug it in, but you're kind of wasting time. So we got 4 pounds of oranges, 8 pounds of apples. Obviously, those add up to 12. And if we take on the apples, okay, $1.99 times 8 plus the oranges, $1.50 times 4 gives me $21.92. So that's right. Now, next problem. We're going to set up the table ourselves now. At a football game, student tickets cost $3 each. Adult tickets cost $5 each. The school sold 700 tickets. They made a total of $3,078. How many adult tickets, how many student tickets were sold? So we're spending money, but we're not spending it just on one thing. It's a mixture of two things. So again, the input-output table is worthless. So I make my grid here. So there's a third unit added into the problem. So you put together on top here. And then these are the two things that you're buying, which would be student tickets and adult tickets. And you can abbreviate if you want, but you got to know what's what. Then down the row I put how many units per unit and total. So I have money total, money per unit. This is not money related. So I like to fill this row out first. So what's the only number that's indicative of how many? It wouldn't be that, again, that's cost. It doesn't go on top. If you put money on top, it's wrong. Okay? Nope. 700 tickets would be indicative. Okay? And it just says they sold 700 tickets, so that would be your together amount. And then these are unknown because those are the answers. So I'll let students be X and adults be Y equals 700. Now after that top row is filled, I go to the bottom row, and what's my total? $3,078. Okay. Okay, since I have this value and this value, this is not needed. Okay. So the dollars per unit, well, the students cost $3 and the adults cost $5. So then to get to these values here, okay, $3,078 is my total. That's from selling X number of student tickets, and then times 3. So X times 3 is 3X. And then Y times 5 is 5Y. Now we have our two equations, up here and down here. So I stack those up. So you have X plus Y equals 700, and then 3X plus 5Y equals 3,078. Okay, I would employ the elimination method. So I multiply by 3 and by 1. So you get 3X plus 3Y equals 2,100. And on bottom you get 3X plus 5Y equals 3,078. Okay, you need to make the bottom negative out the bottom. So I get 0x when I add. When I add here, I get negative 2y. And when I add here, I get negative 978. Okay. Now, we zero the x out, and the plus is not needed, so it's negative 2 times y equals negative 978, so I divide by negative 2. And negative 978 divided by negative 2 is 489. So I go find my y, it's right there. So you have 489 adult tickets. Okay, now the student tickets, I mean, you can plug it in, but if you just look up top, what number plus 489 is 700? Well, how about we subtract and find out? It's 211, okay? So X is 211. So 211 student tickets. Next problem. A student sells small and large greeting cards. The small cards cost $3 each, the large cards cost $5 each. The student sells 25 cards. They make a total of $95. How many of each type of card were sold? So we're spending money, but it's on two things together. So together, the two things we're buying together are small and large cards. So small, large. How many units per unit total? Okay. Okay, so fill out the top row first. What's the only number that's indicative of how many units? Well, not the costs are not viable to put there. So the only thing I got is a 25 cards, and that's together then. So these are unknown, so it's x plus y, because that's what I'm trying to figure out. Okay, now, bottom total, $95. So out. So this is not needed. That box will not be necessary. Okay, oops, I forgot to put my dollar sign. Okay, now my small, well, the small costs $3, the large costs $5. So to get down here to your total, you get the total by buying X units of small cards times $3, which is 3x. Okay, we don't know how many large, y, and we multiply that by 5y. Okay, so we have the two equations. Stack them. So x plus y equals 25, and 3x plus 5y equals 95. So I would multiply by 3 and by 1. So 3x plus 3y equals 75. 3x plus 5y equals 95. Okay, negative, 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 and you're adding. So this gives you 0x, which takes that out. This is negative 2y, and this is negative 20. Then I divide by negative 2 and I get 10. So y equals 10. So we know that we have 10 large cards. And then to find the x, well, 25 minus 10 is 15. So I can kind of do that mentally. Okay, and that's how you do that. I'm not going to do the next one. We already did an apples and oranges. Okay, now the game's going to change on the next part. You have to read the problem. A pet store sells angelfish and clown loaches. They sell 2 angelfish and 6 clown loaches. They collected a total of $36. If angelfish cost $2 more than clownfish, what was the cost of each type of fish? So we're finding what the angelfish and clown loaches cost this time. We know how many of them there are, but we don't know what they cost. So angelfish and clown loaches. And money total, money per unit. Now across the top, we have actually 2 values that are indicative of how many. 2 angelfish and 6 clown loaches. So 2, 6, and add those together, you get 8. Now that's not an equation, so we're not going to get an equation on top. 2 plus 6 makes 8. Now jump down here. Your total is $36. Now, this is not needed. Now, what about these two? We know something about what they cost. That's the answer to the problem, but we know that the angelfish cost $2 more. Now, here's what you have to do. you need to put plus 2 in the angelfish column. Don't just put 2, it's plus 2, okay? So angelfish is plus 2. And you got to read the problem to know which one's more. Now, question for you. We don't need y, okay? So I shouldn't see you put a y. When you have that plus amount with two unknowns, you can express it in terms of the same variable. So we're going to have angelfish as x plus 2 and clownfish as x, okay? So when I have that more than comparison, I don't need the y variable, okay? It's just x plus 2 and x. Now you're going to put a parentheses around that because you need to distribute. So it's 2 times the whole quantity x plus 2. So we take 2 times x and 2 times 2, and that's 4x, or excuse me, 2 times x is 2x, 2 times 2 is 4. So in this column I now put 2x plus 4, 2 times x, 2 times 2. Then 6 times x is 6x. Okay, now pretty much the only equation we have is down here, and that's all we need because there's only one variable. We don't have to solve for two different variables, so one equation will do. Well, you combine your x's into 8x plus 4 equals 36. Then you subtract 4, and you get 32. Then you divide by 8, and you get 4. Okay. So go find where the x is all by itself. This is the box that contains just x. So this is 4. So the clown loaches cost $4. Now what do the angelfish cost? Well, it's 4. X is 4 plus 2. Okay. And 4 plus 2 is 6. $6. Okay. Cross out the next problem, please. Hardcover books cost $3.50 more than paperbacks. $198 was collected from selling 20 hardcover books and 12 paperback books. Find how much each type of book cost. So again, you're spending the money on, but you're spending it on two different things. So the input-output table and the line isn't going to work. So you have together. What are the two things you're buying? Well, paperback and hardcover. Now, how many units per unit and total? Okay, now how many units? Well, that is not how many, that's a cost, okay, because remember, the cost is for these right here. Well, I see 20 and I see 12. 20 hardcover, 12 paperback. So together that makes 32. So no equation there. No unknowns there. Now I go down, fill out my total, okay, and the total is $198. So this is not needed then. Now, these are the unknowns, what they cost per unit of paperback hardcover. Well, the one thing we know is that the hardcover costs $3.50 more, okay? Now, it's hardcover. Don't put plus $3.50 right there because it says the hardcover costs more. So the plus $3.50 is hardcover. And when you have that two unknowns but you know the plus, you don't use y. So don't put y and x. You put x there and x there. You can write both your unknowns in terms of x, okay? So 12 times x, well that's 12x. Plus, then I parenthesize that expression because I need to apply the distributive property and take 20 times the whole quantity at 3 times 350. Okay, so 20 times x, 20x. 20 times 350 is 70. So 20x plus 70. Now, this is the only equation you got, but it's the only one you need because you did not use another variable. So I combine my like terms of x, 32x, plus 70 equals 198. Then I subtract the 70, and that's 128. And I divide by 32, and 128 divided by 32 is 4. So here's the x solo, so that's your paperback book cost. and then 4 plus 350 is 750. Okay, last one. At a play, $2,995 was collected from tickets. Adult tickets cost $2 more than the student ticket. Sorry. 325 put students. I shouldn't have wrote children. I'm an idiot. 325 students and 404 adults attended the play. Find the cost of each type of ticket. So you got together, and the two categories of things are the adult tickets and the student tickets. So how many units per unit and total? Then of course money total and then money per unit. So find me how many units. That's a cost. That's a cost. So I think I've got two of them. 325 students, 404 adults. So 404 for adults, 325 for students. You add those together, you get 729. So no equation there. Okay, the equation here is when I know the together, and then I have to label the x and y, but that's not going to happen here. Now your total is known. That's $2,995. See ya, see ya, see ya. Everything. Now I don't need this cent because I have these two. Okay, adults cost $2 more, so you put plus 2 in the adults. Whatever one's the one that costs more is where you put the plus amount. Okay, more means plus. And we can write these both in terms of x. We should not be using a y, so x plus 2 and x. So to multiply, I need to take 404 times the expression x plus 2, which means I distribute 404 to x and 404 to 2. So that's 404x plus 808. And right here, 325 times x is just 325x. Now you have just the one equation. That's all you need because you just have to solve for the x variable. You don't have to solve for x and y like you did in those first ones that we did. Combine your like terms of x, that's 729x plus 808 equals 2,995. So I subtract 808 and divide by 729. $2,187. Then I divide each side by 729. That takes me right to my answer. I got 3. So x is 3. So for student tickets, the cost per unit is $3. And 3 plus 2 makes 5.